Hello, everyone. Myself, Dr. Thrimurthulu, Professor in CSA Department, MLR IT, and this is my fifth video in Introduction to Artificial Intelligence subject. And today's topic is AI Space Search Algorithm. And in last class, I covered the AI agents and its environment. And today, I am going to cover state space problem and its components and type of the search problems and uninformed search algorithm, informed search algorithm, comparison between them, and how the process is going on search algorithm. And one of the search algorithm today's class I am discussing. Okay, and coming to the formal description of a problem. Generally, AI is the study of building agents that act rationally, and most of the time these agents perform some kind of search algorithms in the background in order to achieve their tasks. So that search algorithms are one of the important key factors in artificial intelligence. Okay, a state space is a mathematical representation of all possible configurations or states of problem, and used in search algorithms to find a solution. And all the problems we are describing in a state space problem. State space. Okay, this is the mathematical representation of all possible configurations in that problem. And problem solving is a method of deriving solution steps beginning from initial description of the problem to the desired solution, the goal reaching. And in AI, the problem are frequently modeled as a state space problem where the state space is a set of all possible states from start to goal states. There is in between, there is the intermediate states are there. So general problem solving how it is. The problem solving is the process of generating solutions from observed data, whatever the environment you are getting the perceptions from the perceptions that is observed, that is the data with that. So here a problem is characterized by a set of goals and a set of objects and a set of operations is going on in that. And this could be held defined and may evolve during problem solving. Okay, many steps are involving and searching solutions. What are the how we are going to get the solution to build the system to solve a problem? Define the problem precisely. That is the one thing, and analyze the problem what it is, and isolate and represent the task knowledge that is necessary to solve the problem. So the best problem solving techniques or strategies and apply it to the particular problem. And coming to the what are the major components in that? So state space search in artificial intelligence involves four key components are there. One is the initial state or start space, initial state that you are called as a start state, and there are the successor functions are there where there are the rules or operation rules are there based on that the states are functioning, and there is the in between intermediate states are there, and the third one is the goal state, goal test, and fourth is the path cost function. These are the important key elements in that. Suppose this is the flow diagram is there, you are initializing whatever the problem is there, the problem you are initializing the problem, you are identifying problem your definitions you are identifying, you are initializing the starting node, setting the current state, the initial node as a current state. Okay, that you are setting the current state. Then is it the goal state you are comparing with that? Is it the goal state? If it is the goal state, then the algorithm will terminate. Otherwise, return the solution. If it is not a goal state, then generating the whatever the possible states, all the possible solutions it is generating. And already if you are visited that particular node or vertex, then you are skipping that one. Otherwise, you are going to that particular nodes, you are evaluating those nodes. This is the continuous process is going on like this. Okay, and the initial state represents the starting point of the search. Whatever the initial state, that is the starting point of the search where you are starting that point. The successor functions generate all possible next states from a given state representing possible actions, that is based on the algorithm, whatever the strategy you are applying based on that. The goal test determines if a state is the desired solution or not, whether you have reached the goal state or not, it is testing. Goal test is the one of the function. Finally, the path cost function assigns a cost to each transition between the states. What is the path cost from current state to next state or current state to goal state? What is the path distance? You can calculate it. So these are the main key components. 4 key components are there. This is the flow diagram in that. Then going to the what are the types of search algorithms? Basically, the search algorithms, there are 2 types. One is the uninformed search algorithm, the other one is the informed search algorithm. See, uninformed search algorithm, that you are also called as a blind search algorithm. Informed search algorithm, that is you are also called as a heuristic search algorithm. So these are the uninformed search algorithm. There is the various types are there. Breadth first search algorithm, uniform cost search algorithm, depth first search algorithm. There is the variants are there in depth first search, that you are also there. Depth limited search or depth bounded search, and iterative deepening depth first search, bidirectional search. All these are the uninformed search algorithms. And a few informed search algorithms I have mentioned here: best first search algorithm, A star search algorithm, hill climbing search algorithm, simulated engineering algorithms like this. Those are the informed search algorithms. Coming to the uninformed search algorithm. So uninformed search algorithm in AA refers to a type of search algorithm. It does not use the additional information. It doesn't have any information about the goal state. It doesn't have any information about the goal state, and only problem we knows. Defining the problem only we knows. Okay. So information to guide the search process. There is no information to guide the search process. So that's why you are also called as an uninformed search algorithm, is also called as a blind search algorithm. So these algorithms explore the search space in a systematic way. One systematic way blindly you are following. Okay, systematic way you are following, but blind the manner without considering the cost of reaching the goal, because you are not considering the what is the path cost, we don't know. So that's why it is the blindly you are moving systematic way to reach the goal. That is the main thing, or the likelihood of finding a solution. So this is the uninformed search algorithm. It doesn't have any information about the goal state, so that one systematic way you are starting, you are reaching the goal. So examples of breadth uninformed search algorithms are breadth first search algorithm, depth first search algorithm, depth limited search algorithm, iterative deepening depth first search algorithm. These are the examples, few examples. So here, what are the key features in uninformed search algorithms? There is the systematic exploration is there, because it doesn't have any information. We are starting initial state. From that, we are finding the systematic way. We are one by one, we are evaluating the nodes and testing those nodes. Uninformed search algorithm explores the search space systematically, either by expanding all children of a node. Whatever the children, all the nodes we are expanding. All the children nodes we are expanding, we are visiting those nodes, and we are testing those nodes whether it is the goal state or not. Goal test it is going on every time, and like that way, systematic way, we are going, exploring as deep as possible in a single path before backtracking. Before backtracking, we are visiting all those nodes. Okay, no heuristic, because it doesn't have heuristic means there is no information, previous information. There is no heuristic information. So uninformed search algorithms do not use the additional information such as heuristic or cost estimate or guide the search process. It doesn't have this uninformed search algorithms. So it is a blind search algorithm, blindly or following systematic way. Uninformed search algorithms do not consider the cost of reaching the goal. Only our target is reaching the goal of it is. We are not considering the cost, because it doesn't have any information about that. So that what happens, or the likelihood of finding the solution, that is the one thing leading to a blind search process, that is. And it is simple to implement. This is the very basic algorithm, simple to implement. and are often simple to implement and understand, and making them good starting point for more complex algorithms. It is the starting stage. This is the based on that there is the algorithms are extended, advanced algorithms based on that they are developed. So it is inefficient in complex problems. If it is the large data set, this kind of uninformed search algorithms it won't support, because it is the infinite loop is there means it doesn't support. Those are the things. So here search algorithms can be inefficient in complex problems with large search spaces, leading to exponential increase in the number of states explored. So that is the one thing. And that uninformed search algorithms, there is no guarantee to find the optimal solution, but definitely your completeness is there, you are definitely reach the goal, but we are not getting the optimal solution. That is the one thing. So do not guarantee an optimal solution. That is the one thing. They do not consider the cost of reaching the goal or the other relevant information about the goal state. So these are the uninformed search algorithm key parameters. And coming to the informed search algorithm. So informed search algorithm, it is advanced somewhat. We have additional information about the goal, and we have a heuristic function. Heuristic cost functions or estimations are there. So that this is the one of the best algorithms. So it is the more efficient for problem solving as compared to uninformed search algorithms. So this information can be in the form of heuristics, that means estimate the cost, estimate of cost, or other relevant data to prioritize which states to expand and explore. So examples of informed search algorithms include A-star search algorithm, best first search algorithm, beamstack algorithms, greedy search algorithms, simulated annealing algorithms. Those are the informed search algorithms. So what are the key features of informed search algorithms? One thing, it has a heuristic information is there. You have some information about the goal state, whether it is the cost estimation or some other information. Informed search use the heuristics or additional information to guide the search process, and prioritize which nodes to expand, so that that particular nodes only can expand, so that the complexity problems will reduce. It is the more efficient. Informed search algorithms are designed to be more efficient than uninformed search algorithms, such as breadth first search and depth first search, by avoiding the exploration of unlikely paths. Okay, only prioritized focused only. You are focusing on the promising nodes only. That is the advantage in this informed search algorithms. So goal directed, it is the focus mainly on the goal direction only. Informed search algorithms are goal directed, meaning that they are designed to find a solution to a specific problem. And moreover, it is the cost based. It is a cost based. Informed search algorithms often use cost based estimates to evaluate the nodes, the least path, shortest path you can find out, shortest cost path you can find out, so that you are getting the optimal path. So, such as the estimated cost to reach the goal, or the cost of the particular path, and prioritization. So prioritization means informed search prioritize which nodes to expand first based on the heuristic information or additional information available, often leading to more efficient problem solving, because you have every cost estimation is there. Based on that cost estimation, you can prioritize that one, the best node, here you can expand it, evaluate. Then optimality is the another important. This is definitely getting the optimal solution. So may guarantee an optimal solution if the heuristics used are advisable within the limits. The advisable means here what it is, whatever the estimated cost should be less than or equal to the actual cost. That is the advisable parameter. And consistent, then you will get the optimal solution. So it is the optimality, the another key feature here. Definitely will get the optimal solution for these cases. Then coming to the comparison between the informed search algorithms, uninformed search algorithms, each and every parameter you can identify here. So this informed search algorithm known as heuristic search algorithm, the other name. Uninformed search algorithm is the blind search algorithm. There is the one parameter. So using the knowledge. So it uses the knowledge. Additional information is there in this case, in informed search algorithm. It doesn't use the knowledge for the searching process. Performance. It finds a solution more quickly. It finds a solution slow because you are systematic way you are finding one by one node. You are reach to the goal. So compared to an informed search algorithm, this is slow somewhat. And completion. It may or may not be complete. Sometimes informed search algorithm, it always complete. You are getting the complete solution. Cost factor. The another one is the cost is low in informed search algorithm. Your cost is high because you are one by one node systematic way blindly are approaching. That's why the cost factor is more. Time it consumes less time because quick searching, because only prioritized nodes only are expanding. So that the time is very less here. It consumes moderate time because slow searching, because you are evaluating all the nodes, you are visiting all the nodes. Direction. There is a direction given about the solution based on the strategy or algorithm. No suggestion is given regarding the solution in that. There is no heuristic information, additional information, which node you have to expand like that. Implementation. It is less lengthy while implemented, whereas it more lengthy while implemented. Implementation is somewhat more cost. Efficiency. Coming to the efficiency, it is more efficient as takes into account cost factor also and performance also, time complexity, space complexity, point of view also, it is the more efficient, so that you are getting the shortest path or optimal solution, definitely will get it. It is comparatively less efficient as incurred cost is more and the speed of finding the breadth first solution is slow in these cases. The computational requirements are lessened. The high computational requirements are needed here. The size of the problem. So these informed search algorithms are whatever the complexity also, large complexity problems also it can handle. Whereas this one, large complexity problems, it doesn't support, only small problems, small complexity only it is supporting. So what are the examples of algorithm? Greedy search, A star search, AO star search, Fleming algorithm, these are the informed search algorithms. Depth first, breadth first, and branch bound or uniform cost, all these are the uninformed search algorithms. Then coming to the process of search algorithms, how it is going on, because each of these uninformed search algorithm process, here the problem graph, you have a tree traversal graph is there, or a graph tree is there. Based on that, a problem graph is there containing the start node S and the goal node G. We have a starting node you have mentioned and a goal node, how you have to achieve the goal. A strategy are applying. In uninformed search, there is the various strategies or algorithms are there, which strategy are applying based on that. Describing the manner in which the graph will be traversed to get the goal node. A fringe, that is the important parameter, which is the data structure used to store all the possible states, whatever the possible stores nodes information you are storing in fringe, that you are called as a fringe data structure, that you can go from the current state to the goal state, all the information you are keeping in that fringe. A tree that results while transversing to the goal node. A solution plan, which the sequence of nodes from S to G, how we are approaching based on this strategy. Then coming to the one of the example, breadth first search algorithm, we will discuss now. So breadth first search is the most common search strategy for transversing tree algorithm. It is a graph based tree algorithm, and this algorithm is also called as a blind search algorithm, one of the blind search algorithm. This algorithm searches breadth wise. The name itself, it is their breadth first, breadth wise in a tree or graph you are searching. So BFS algorithm starts searching from the root node of the tree and expands all successor nodes at the current level before moving to nodes to the next level, because you are starting root node, you are starting in that level based algorithm. This is also called as a level based algorithm. So you are exploring the first, you are visiting all the in that levels, then only you are backtracking to, you are going to the next level. So this breadth search algorithm is example of general graph search algorithm also. And this is the data structure implemented using the PIPO, first in first out queue based data structure. This is queue based data structure, whatever the data information you are storing, nodes information. BFS operates exploring the graph level by level, each level, because this is the level 0, level by level you are exploring all the levels in systematic way. This is a level based algorithm, starting from the given node and expanding outward based on the distance. So here the algorithm of it is means there are the different steps are there. Mark the start node as visited node. First you can start with the S node, that is the root node, and you can start with that. You can test whether it is the goal node or not. If it is the goal node means your solution is reached, you are terminating the algorithm. Otherwise you are going to the next level. Next level, what it is the A is there. In the starting node level, step 1, in step 1 what is the fringe field? The fringe is the only A information only it is stored, S information only you have stored, this information you have stored. Then whether it is the goal node or not, it is not a goal node. Again you are expanding, you are going to the next level. Like you are visiting A, then you are expanding the S. When you are expanding this, it has a two nodes are there, child nodes A and B. And the next step 2, the fringe field is the A and B. A, B information you are storing in that level 1. You are visiting the A and you are visiting the B, and every visit you are testing with the whether it is the goal node or not. The algorithm will check. So mark the start node as a visiting node, remove the node from the queue, and you are keeping in a S as a queue initially, and we are removing that one, you are expanding. Then in the queue what it is, you have keep it in second step A and B, you have kept the information in the queue. Then add all unvisited neighboring nodes of the current node to the queue and mark them as visited. Then repeat these two steps continuously. Every time you are expanding that one, you are keeping in queue, and one by one queue you are expanding, and whatever the expanded node, already visited node, you are removing that one, the new nodes it is adding to the next. Like that way, the first in first out, whatever the first in queue, that you are removing, next it is coming. Okay, like here A and B step 2. So A is not a goal node. Goal node is the K suppose. So A is not a goal node, and then you are going to the next neighboring, next level, in the same level whatever the B is there. Here B is not a goal node. Then you are backtracking to the next level. Next you are going to the next level. Next level what it is, A as a two nodes are there, C and D. So that A is removing in the queue, and instead of A, what is the next step? B, C, D. Because you are adding these two nodes, C and D. They can check it whether the C is the goal node or not, or D is the goal node or not. Then again you are expanding the B node. Then remove the B node also from the queue. Then next step what it is, you are removing the B node also here, and CD is there. Then GH is there. These are the fringe information data structure you are maintaining like this, first in first out. This is the first in, this is the second in, this third in, like this first in first out based queue based algorithm this is. So like that you are checking all the algorithms in that level, all the things you are visiting one by one, you are checking. Then you are going back to the next level. In that also you are checking E, next level what it is, you are expanding the C, so that you are removing the from the QC, then D, G, H, then E, F information you are keeping. Okay, that information you are keeping in the Q structure. So E, then F, then what it is, you are expanding the C related, I also is there. So then D doesn't have any nodes, and G information next, D you are removing, then you are adding that D information also high. Then it is not a goal node, so that you are going back to the here. Then K is the goal node, so that you are reaching the completeness is there, you have reached the goal. So like that you are approaching all these things one by one, level by one. You are going here, you are revisiting this one, then coming back to here, next level, you are visiting all the nodes, then coming back to here, visiting all those nodes, then reaching the goal. Finally, you got the goal node. Like that way, the breadth first search algorithm is searching level by level based. You are searching one by one node, and it is the queue based algorithm. The another example also is there here how it is. So what are the advantages in this case? BFS provide the solution. If any solution exists, there is the goal is there, definitely will get it. If there is more than one solution for a given problem, suppose the goals are in different places or the same goal is there, then BFS will provide the minimal solution which requires the least number of steps. Suppose the goal node is here itself is there, means in this level 1, then immediately you are getting the information, you are terminating the algorithm, you got the goal like this. So that's why if it is the more solutions are there, it is immediately will get it, and completeness also is there. That is the advantage in this case. And the BFS requires lots of memory, because in Fringe you are storing all the information in queue. What all the nodes you are visiting, all the information you are keeping in that. So lots of memory requires. Since each level of the tree must be saved into memory to expand the next level. So BFS needs lots of time if the solution is far away from the root node. Suppose if it is the problem is the large complexity problem, there is the many nodes are there. Suppose that nodes means if it is the infinite nodes means it is very difficult to get the completeness. It takes a lot of time. So in this case, see, this is the root node. From the root node, we are checking again. You are going to B. We are visited C. Then you are coming back to the next level, level 2. There the D is there. There is not a goal node. E, F, G, like this you have visited. Then finally got the K. Goal node is here last at the end. So that this is the path. This is the path for reaching the goal. A to A, the starting node, to the goal node K. This is the way you are approaching. Then coming to the what are the complexity analysis, and what is the time complexity, how much time it is taking, what is the space, how much memory it is occupying, that you are called as a complexity analysis. Okay, in this what it is, the time complexity in breadth first search is the O is the operation, and V is the vertex, nothing but a node, sometimes you are called as a node, and E is the represents number of edges, nothing but a branches, number of branches, sometimes you are called as a V nothing but a N, or E nothing but a B, like this. So that operation cost is N V plus E, depending on the number of nodes and the number of branches connections are there. Based on that, the operation cost is there. So that the time is more. It explores every, if it is the goal is very level nearby, means nearby the root node, means you will get the within a short span you will get the BFS explores every vertex, examines each edge, and resulting in this linear time. It is the linear time complexity. This makes efficient transversing graph, whether the large or small scenarios. If it is the best case, means best means immediately will get it. If it is the root goal node is near to the starting node. Worst case means BFS needs to explore the entire graph before reaching the target node. That is the worst case. At the edge last it is there, means that is the worst situation. Average case, BFS typically explores multiple levels of the graph. So that are the different scenarios. Then space complexity. Space complexity is nothing but how much memory it is occupying. So this space complexity, where the V is the number of vertices, this is because BFS, this operation is the V, whatever the number of nodes, that depends space complexity. All the nodes information you are keeping in the fringe field. So a queue to store vertexes that are waiting to be explored, a visited set to track which nodes have already been visited. So in worst case, the size of the queue could be large. In the worst case means if at the last it is there, means it takes much space, memory space. So these are the memory usage. In this case, is the memory needed for BFS depends on the graph size, how big the graph. If it is a small graph, means less memory only it is occupying. So that depends on the number of nodes. These are the complexity. So today's class I covered the state space problem, because every problem your definition you are saying as a state space. Okay. There are the different states are there, starting state and the goal state, intermediate stores. There is the goal test function is there, cost function also is there, and based on the function, nothing but a strategy you are approaching. There are the different components we have discussed, and there are the two different types of algorithms, uninformed and informed search algorithms, and what are the comparison also you have discussed between them, and how the processing going on such algorithms. It is a fringe of every information you are keeping in the fringe. So then one of the best first search algorithm, yeah, I have discussed here, and we have analyzed the complex analysis also, how much time it is taking, how much space, and advantages, disadvantages I have discussed in this video. Coming to the any queries, please mail me, and then my next video covers the remaining uninformed search algorithms. I will discuss depth first search algorithm, depth bounded first search algorithm, iterative deepening depth first search algorithm. All these are the variants of the depth first search algorithm. Their advantages, disadvantages, I will discuss in the next video. Thank you very much.